Hey guys, welcome to the video on the digestive system. Now, I normally use this as a review, so this doesn't follow your notes exactly, but as we go through, if you can try and fill out some things as we go, that would be really helpful. Again, this is not as fully in depth as we're going to go in class because there are some extra things I want to talk about, but we're going to get started right here at the mouth. So if you go into your notes, find the section on the mouth. Like I said, whatever you can fill in would be great. So, diagram. So the mouth, the important part about the mouth is actually not the fact that you chew your food or mechanical digestion. The mouth does both. It does mechanical and chemical. And chemical is actually probably one of the most important parts. So chemical digestion just means breaking down food using enzymes. So in our mouth, we have two places where we have salivary glands, one at the back and one at the bottom. And what it does is it secretes saliva. Saliva is fairly neutral. It's about a 7 to 8 pH, but it has inside of it water and mucus to help lubricate our food, moisten our food, help us get that flavor from our food, and to ensure that we don't choke on our food as we swallow it down the esophagus. But probably the most important about this part about the saliva is the salivary amylase that is found inside the saliva. Now, you'll notice as we go through this video, any enzyme I have will be marked up in red. So you can add it to your notes somewhere. Make sure you know it's an enzyme. It also ends in ASE, which is a good way to know. So salivary amylase is where carbohydrate digestion occurs. Carbohydrate digestion happens in the mouth and in the small intestine only. Okay, so I'm going to talk about where each macromolecule is fully digested and as we go along. So when we chew a piece of bread or we eat some pasta or we eat a complex carb, we're breaking it down from the starch into maltose, starting in our mouth with salivary amylase. Once we've started to break down the carbohydrates, all we've done to the lipids and the proteins is chew them. There's no chemical digestion here. Nothing is being broken down. Then we swallow it down, it goes down our esophagus, and it passes through the epiglottis area and then to the sphincter of the stomach, which is called the pyloric sphincter, and it enters into the stomach right here. So once you've passed the food into the stomach, okay, these things called the gastric pits, they're like deep pits, or the glands in our stomach, start secreting gastric juices. The gastric juices inside our stomach are extremely acidic, pH of 1 to 2. Okay. Now, inside the gastric juices, we have mucus again to continue to lubricate the food as it passes. But we also have HCl, so hydrochloric acid. This is an associate, not enzyme, but acid. It's not breaking anything down. It's just help loosening protein fibers. So you'll notice it's in blue. It's not an enzyme, so I don't have it in red. So again, HCl is the reason why we don't always get food poisoning. Sometimes we do, but most of the times we can eat food and it can be digested and kills all this bacteria because it's extremely acidic in our stomach. But then we also secrete something called pepsin. Pepsin is a very important enzyme. Unfortunately, it doesn't end in ASE, but it is a super important enzyme because it starts to take proteins that are in these like big globular structures, that quaternary structure, and it starts to stretch it out so that we can start cutting it up, okay? You'll notice that at this point in time, there was no digestion of proteins here. The first part of protein digestion is in the stomach, okay? So it looks like this. We go from this beautiful quaternary structure to a stretching out structure or a primary structure. We want it to be a primary structure so we can break it into polypeptides and further on down the line. And I'll kind of show you guys that in class on the board. Once it's left the stomach, all of the food that we ate, so if you ate a meal that had carbs, lipids, and proteins are going to be starting to digest in the stomach. They're going to now pass into the duodenum. But what we're going to talk about right now is this tiny little space right here by the duodenum. So the duodenum is the start of the small intestine. As food leaves the stomach and enters into the duodenum, there's this setup. So here's your liver, here's your gallbladder, here's your pancreas, and here's the duodenum. You're going to notice the gallbladder and liver have these things called the common bile duct, and the pancreas has something called the pancreatic duct that empty out into the duodenum. So I'm going to stress this. I'm going to say it so many times, and it's so important. Food does not pass through the liver, it does not pass through the gallbladder, and it does not pass through the pancreas. Instead, we call these accessory organs. Those organs secrete enzymes to help digest food in the small intestine. So there's no food passing through them. So we're going to look specifically at the liver and the gallbladder. So the liver, which stores the gallbladder, secretes bile. Now, you're probably thinking, what is bile? If you've ever been super sick with like the flu, or you've been like not feeling good and you've thrown up everything you can, but you still dry heave, and then all of a sudden you start throwing up this like yellowish, greenish substance that's extremely, like it burns, that's bile. It's stuff coming from your liver. Now, what's the point of it? Well, it's supposed to be a pH of 8, and its job is a couple key things. The first thing it does is it has bile salts in it. Okay. Now, bile salts, again, are not an enzyme, but their job is to attach themselves to lipids and emulsify lipids, meaning when it attaches to lipids, it makes the lipids kind of spread out a bit more so that it increases the lipid surface area. Because at this point, we have not digested any fats, none in the mouth and none in the stomach. Okay. So once we hit the duodenum, fats or lipids start to get some sort of digestion occurring. This is not digesting lipids, but it's giving the lipids the surface area to ensure that they can be digested. The other thing the liver and the gallbladder secrete is something called sodium bicarbonate. Now, you don't want all this acidic acid from your stomach entering into your duodenum. So as food passes into the duodenum, we secrete sodium bicarbonate to help neutralize the acids from the stomach. And it also provides a basic pH in the duodenum so we don't have any complications or burning through the whole of the duodenum. Now, this is just an example of showing you what emulsifying a fat would look like. The fat drop looks like that. We add bile in it. Now, all of a sudden, I have all these tinier drops that I have way more surface area to attach enzymes to. That is called emulsification. So now we're going to talk about probably the biggest key accessory organ in this entire video, and that is the pancreas. The pancreas does so much. So it secretes pancreatic juices. Again, pH of 8. Sorry, I'll go back to that. I kind of went fast. But what you're seeing now is the pancreas has so many things. One, it also does sodium bicarbonate, but then it also does this enzyme called trypsin. Trypsin and chymotrypsin are actually from the pancreas, and they break down proteins even further. So remember when I said pepsin straightens them out from their crazy spaghetti looking to like a single spaghetti noodle, okay? That noodle is a whole piece of spaghetti. What we're doing is we are chopping it up. So think of it as a long beaded line, and we're going to come take trypsin and we're going to break it into smaller pieces. Now, because these pieces have like 12 to 1,000 amino acids still attached, it's not 1,000, but they're still considered polypeptides. So trypsin takes it and takes it from the big polypeptide into smaller polypeptides. Then comes the peptidases, which are now protein enzymes, and they take that shorter polypeptide, which trypsin made, and then they cut it into the dipeptides all the way down to the amino acids. So now we have the monomer of proteins hanging out in the duodenum, okay? So that's the stuff our body wants. It's made by being digested and broken down in the duodenum. We also secrete something called pancreatic lipase. You'll notice the front part of this word is LIP, probably meaning it is going to act upon lipids. ASE, it's a lipid enzyme. So the pancreatic lipase takes any triglyceride we've eaten and breaks it down to the glycerol and fatty acids. Now it can do that because earlier on, bile salts from the liver gave us lots of space to break them down. Okay, so right now in the duodenum, we now have amino acids and glycerol and fatty acids, the lowest monomer we can get for both proteins and fats. The last thing that's secreted into the duodenum is pancreatic amylase. And again, we started digestion of carbs in the mouth. We're going to continue digesting in the actual duodenum. Now, the pancreatic amylase is secreted to continue the breaking down of starch into maltose, okay? So that's everything the pancreas does. It's quite a bit. So now let's look at the actual duodenum. So we now know inside the duodenum, we have monomers of proteins, which we call amino acids. We have the monomers of lipids, which are glycerol and fatty acids. How do we get the monomers of carbs? So the intestinal wall of the duodenum secretes intestinal juices, again, pH of 8. And these ones have, again, peptidases, so a little bit more digestion of proteins. But then they also contain all the carbohydrates, as we've talked about in class. So the duodenum is creating the monomers of carbohydrates, the monosaccharides. It secretes maltase, sucrase, and lactase to break down all the disaccharides into their monosaccharides. So to get us glucose, fructose, and galactose, so our body can use them for digestion. So far in the story, we have talked about your mouth, your stomach, and your duodenum. With the duodenum, we've talked about the liver and the pancreas and the gallbladder. The duodenum is just one part of your small intestine. So that's right here. So currently, right now, all the food you have eaten or are going to eat has been broken down into all their monomers right here. So amino acids, fatty acids, and glycerol, and monosaccharides. They're going to leave the duodenum and start entering into something called the jejunum, which is right here. The jejunum is also part of the small intestine. Okay, but it starts to do what we call the absorption of nutrients. So now we have all the monomers that we need to absorb into our bloodstream from being digested in the duodenum. Now we need to actually put them into our bloodstream. Okay, so that's the start of the jejunum, but then comes the ileum right here. This is a big player. Okay, ileum is where all of the absorption is going to finish off. Okay, there's so much surface area and it's so full of blood, rich blood supplies, lots of veins and stuff, that we can absorb all the nutrients. So let's look at the ileum kind of a little bit closer, okay? So we are now, with all of the monomers of proteins, lipids, and carbs, we're absorbing them into our bloodstream and to the lymphatic stream. And this is what it looks like. Here's our small intestine, the ileum. It's ribbed inside. It's all ribs and what you're seeing here are these ribs are actually all the surface of the small intestine. It's creating tons more space so that things, as the blood rushes through, it can get passed. As food rushes through, it can get caught up in these little villi, we call them, and absorbed in. Now, the cool thing about the villi is they actually even have more villi. So if you look here at this complete structure right here, this structure is all of the blood vessels and the lymphatic system, which I'll talk about in class. But on top of these villi, okay, are microvilli, even smaller hairs that are trying to trap as much of the nutrients as possible, okay, and drag it into our bloodstream and lymphatic system. So this is why the ileum is so important. It is designed to capture all of the lovely monomers so that our body can do digestion. This is an electronic, oh my goodness. I'm drawing a blank here, guys. Electron microscope scan of the villi. And again, what are we absorbing? Glucose, fructose, galactose, fatty acids, glycerol, and amino acids and nucleotides. Every single monomer from the smallest one down. Once we've left the small intestine, we're almost at the end of the story. We've now hit the large intestine. Okay, so something called chyle enters into this large intestine, and it's essentially everything your body cannot use. It is indigestible matter. Usually plant stuff is in there. We don't have plants very well. Large amounts of water and tons of salts. So as it passes through our large intestine, the main component of the large intestine is to take back all that water. When you have diarrhea, because it happens to everyone, it's because your large intestine is not doing its job properly. It's not reabsorbing the water back into your body for some reason. Okay, so they do this based on the fact that you have lots of salt in the large intestine in the indigestible matter. As salt leaves to go back into the bloodstream, so does water, okay? Because we know water moves from high concentration to low concentration. So if all the salts enter into the bloodstream, now there's not enough water, so water leaves as well, okay? Our large intestine is also full of bacteria, which is super important because it actually does a lot of production of vitamins, and those vitamins are then absorbed by us. So not only should you take a multivitamin every day to help increase the amount of vitamins, but your body actually naturally makes it as well. So there's my little bacteria friends. Okay, so again, what is it doing? It's absorbing water, salts, and vitamins. That's what the inside of an intestine looks like, the large intestine. Once it's passed through all of the intestine, okay, we're going to hit the rectum and the anus, in which we get rid of all the waste that we could not use in our body. So essentially you defecate. And that is the end of the story for digestion, okay? So, ladies and gentlemen, I've breezed over. I've left out some good stories so we can talk about some stuff in class. Again, this is just a brief review of what you're going to see. It's a way to help you remember as we're going through class all the stuff we're going to be talking about. So please make sure that you kind of follow along in your notes and add what you can as you go along. Go back and watch parts of this if you need to, but we will be filling this out and talking about them in class. Have a great day.